Hello and welcome to our 8.7 notes. We are taking square roots today. So we are going to start with a little warm up and we're just going to talk a little bit about inverse operations. So if I have x plus 3, right, equals some number, it doesn't really matter. What we're focusing on here is how to undo this plus 3 part. So we undo that by subtracting, right, because subtracting is the opposite of adding. So if we do that to both sides, these guys cancel out and we get x equals 10. All right, and that's what we're doing to solve each of these. We're just doing the inverse operation. So for number 2, we have x minus 3. And again, I'm only looking at the side with the variable. I don't really care what's on the other side. So I'm just going to add 3 to get rid of the minus 3 and do the same thing to the other side. These cancel out and we get x equals 10. Moving on to our third warm-up problem, we have x divided by 3 equals 10. In order to undo division, we're going to use multiplication on both sides. The 3's are going to cancel out, leaving x equals 30. And then we're going to do the same thing for this one. This one is 3x equals 30. When we see 3 next to an x like that, we know it's a multiplication. We undo multiplication with division the same way we just undid division with multiplication because they are inverse operations. Again, the 3's cancel out. 30 divided by 3 is 10. And there's our answer for that one. And now we have 2 new ones, right? So this says if I want to take a square root of some number that's going to give me 3, right? We can kind of just think about that as a concept. The square root of what number is going to give us 3 as a result. And we might know that that number has to be 9, right? The square root of 9 is equal to 3. That checks out. Okay, similarly, right, that was a square root. Now if I say something squared equals 16, right? Well, now we have to do an inverse operation. So how did we get from 3 to 9? We could think of this as squaring both sides, right? We know that 3 squared is going to be equal to 9. So the square root of both sides is going to give us an answer over here. However, when I'm solving for x squared equals 16, there's actually going to be 2 answers, right? If I square 4, I'm going to get 16. But if I square negative 4, right, negative 4 times negative 4 is also going to get me 16. So when we take a square root, we're going to put the 4 there, but we're also going to put the symbol in front of it called plus or minus, which is going to give us not 1, but 2 solutions. So because we have x squared, that's what's going to give us 2 possible solutions here. So we call these pairs of operations, as we just said, inverse operations, okay? So you're going to hear me use that word a lot. You need to know what that means. So we undo squaring with square roots because they're inverse operations. So if we have 5 squared equals 25, then the square root of 25 equals 5. But of course, it also equals negative 5, right? Those should be closer together, negative 5. Okay, moving on. Taking square roots. So this is our concept here. Here's our steps. We're going to isolate the quantity that's being squared. So that could be just x squared, or it could be x plus or minus a number squared, right, with parentheses. We're going to isolate it using our inverse operations, so just like solving a regular equation. Once we have that part isolated, we're going to take the square root of both sides. Don't forget to put the plus or minus sign, there's the plus or minus, in front of your answer when taking the square root. If there is a negative number in front of the square root, all right, we're just going to say there is no real solution, okay? So anytime you get a negative inside a square root, we can't take a square root of a negative number because that's saying what times itself gives us a negative, right? So if we think about positive 3 times positive 3 would give us positive 9. Negative 3 times negative 3 would give us positive 9. There's no way to make one number times itself. Well, there's no real number times itself that will give us a negative number. Then we're going to simplify the radical if possible. So we're going to look back to our 8.1 notes for that if we need to. and then continue to solve. We will usually have two solutions. Sometimes just plus or minus a number. Sometimes we're going to have two different numbers as our solutions, but we should usually have two. There are cases where we're only going to have one, or where we're not going to have any, right? Like the no solution. Okay, so let's do some examples here. So example A says n squared equals 49. So the first thing we want to do, right, we want to get that n squared by itself, and it is. So we're going to move on to our next step, which is to square root both sides. And on this side with the numbers, we're going to put a plus or minus in front. So remember, like if we add 3 and subtract 3, it's going to cancel out. Divide by 3, multiply by 3, they cancel out. So if I square and square root, those guys are going to cancel out, leaving just n equals plus or minus. And 49 is a perfect square. So if we look at our chart, we know the square root of 49 is 7. So those are our two solutions. We get positive 7 and negative 7. So we could write these as n equals 7 and n equals negative 7. That would also work. So for our next example, we have n squared equals negative 9. When we take the square root of both sides, okay, and put plus or minus, we're going to get the square root of n squared is n. But here, do you guys see how we have this negative sign inside this radical? So this means we're going to have no real solution. All right, anytime we have a negative number inside a radical, we're going to say no real solution. All right. Moving on to number C, we have a little bit of undoing to do, right? We want to get that k squared by itself. So see how that's our thing being squared? So we need to undo everything happening to this. So we're going to start undoing by subtracting 6 from both sides. So again, inverse operations, cancel those out. 206 minus 6 is 200. And then we have to undo times 2. So we're going to undo that by dividing by 2. And we're going to get k squared equals 100. And then finally, right now that my k squared is isolated, now I can square root both sides. Don't forget your plus or minus. And we're going to get k equals plus or minus square root of 100. That's a perfect square. So it's going to be the square root of 10. Okay, for part D, we have this quantity being isolated. So this one has parentheses. This one's going to work a little bit differently, okay? So we're going to go right ahead to square rooting both sides. Right? Don't forget your plus or minus. So when I square root, all it's going to do is cancel out that squared. So we're just going to get x minus 4 left over equals plus or minus radical 25. We know the square root of 25 is 5, so we're going to do plus or minus 5. And now here's where it's going to get tricky, right? I have basically two equations here. I have positive 5 on one, and I have negative 5 on the other. So if I add 4 to both sides, usually what we do is we write the plus 4 first, and then plus or minus 5. Well, this is going to give me two numbers, right? We don't leave it like that because that just means x equals 4 plus 5, which is 9, and x equals 4 minus 5, which is negative 1. So those are going to be our two numbers, right? We don't leave it like that if we can simplify it. So you might have to split it up into two pieces, but we can do that and we can get two numbers. Okay, so for E, again, we don't have x squared by itself. We're going to look on this side of the equation. We see x squared minus 12. So we have to add 12 to both sides. When I do that, I'm going to get x squared by itself equals, and on this side, 12 minus 8 is 4. And now we can square root both sides. And we get x equals plus or minus 4 is a perfect square, 2. So positive 2 and negative 2. All right, last example here. For this one, we are going to isolate x squared, right? So I have to do a couple of things to isolate x squared. This and c, these are good examples if you see one on your homework that looks like this. So subtract 2 to get rid of the plus 2. We get 5x squared equals 25, right? 27 minus 2. Now, we have to divide by 5 before we do that square root part. So now I have x squared equals 5. Oops, forgot my squared. Square root, both sides, don't forget your plus or minus. Now, my last step over here is going to be x equals, because the square root of x squared is x, equals, and here we have plus or minus radical 5. I cannot simplify radical 5, so it just is radical 5. So positive radical 5 and negative radical 5. And that's it for your notes.